annoying.
It's okay.
Then we'll be over with it. Like we'll be done with it.
Yeah. How far have you gone with everything for this week?
I have 2 problems left in the individual exercises. That's about it.
Woo!
I printed off the test. I haven't really looked at it yet. But I think he said if you turn it in by Wednesday or Thursday, then you get 10 extra credit points. So I'm planning on turning it in tomorrow.
Oh, I didn't know that at all.
You like put in the amount. So like if you turn it in, I think it might be Wednesday. If you turn it in by Wednesday, you get 10 extra credit points. And I was like,
Sweet.
say no more. I'll have it done by Wednesday.
I decided to get most everything done this weekend.
Yeah.
So I haven't even looked at my emails or anything. I've just been trying to plow through it.
Your chemistry test got. You had a chemistry test, right?
I'm working on that.
Oh, there you go. At least it'll be done soon. In less than a week, it'll be done.
Yes. I can't wait to get that done.
I don't blame you. All right. Shall we get started?
Let's get started.
Okay. So for problem 1, I use the like using the equation V equals frequency multiplied by wavelength. I said that speed and wavelengths will change, like they change in different mediums. So like they're not always going to be the same if you're going from solid to liquid and stuff like that. So only
Yeah.
the wavelength will change and the frequency doesn't change.
That's pretty much what I said.
Okay.
Frequency is unaffected and wavelength is affected, which changes the speed.
Yeah. Okay, perfect. There we go. All right, for number 2, how did you do it?
So for number 2, I used the equation, the VW equals the VO, which is the 331, times by the square root of T over 273.
Yeah,
So
okay, that's good as well.
so I converted the 24 degrees Celsius into Kelvin, and then I plugged it in, getting 345.24 meters per second. And then since what?
That's what I got. Sorry.
Okay. And then I used the equation D equals VT to find the distance of the sound. And I got 138 meters.
Okay, that's what I got as well.
Okay. And for B, it was pretty close to the same, except so D equals VT, but this time we're trying to find the time or calculate distance. My bad. I messed up a little bit there then.
Well, you do for you like you arrange it, you solve for the T first, and then you plug it in to solve the D. So you
Okay.
first. So I did it. I did the distance we got from the first problem, so 138.096, and I divided it by 3 times 10 to the 8th, which gave me 4.6 times 10 to the 7th seconds.
Okay, that's what I got for time.
Okay, and then I added that to the 0.4 seconds that they said in the beginning of the problem, and I multiplied it by the velocity that we found at the first part of the A, the 345.24, and that gave me 138 meters again, which confused me because they were both 138 meters. So
I think it's supposed to be a comparison.
Okay. Oh, that would make sense. I don't think
because one's based off of sound.
Yeah.
It's okay.
Yeah. Okay. Yeah. So it's supposed to be like, what is?
Yes.
Okay. 4-3. To find the intensity, I did the theta equals 10 log, and then I have the what is it called? W over meter squared. That's the intensity, right? The intensity divided by 10 multiplied by -12. or 10 to the negative 12. And that gave me 36 decibels. And then
Got that.
I did the 36 that we got from that first part minus the 7 that they gave us in the original problem. It was 29. And then I put that into the problem with the beta. So I did 29. Well, I set it up so it was like beta 1 over beta 2. So it's like the same equation, but divided by each other. You know what I mean?
Yes.
B1 equals log 1. Okay. So I did that, and then I ended up with 29 over 10 is equal to log, multiply with the log of intensity divided by 10 to the 12th. And that gave me an intensity of 0.79 times 10 to the negative 9. So I guess you could have done 7.9 times 10 to the negative 9. What did you do?
Okay. So I got a little confused with so I got the 7.94.
Yeah.
And then I was getting a little confused when it came to the 10 to the negative whatever
Yeah.
on both of them.
I messed it up. I put negative 9. I think it should be 7 instead of 0.79. It should be 7.9 times 10 to the negative 10. So I'm changing that.
Okay. Whenever I did, I kept getting a negative 8 for the first one. And then the second one, if I did it right, I end up with the same number, just as a different.
I got the negative 8. But the first one, I got the negative 10.
Okay. I don't think I was doing the exponent right. But I have pretty much the same number.
Yeah. Yeah. So the B, I did the exact same thing except having 29 over 10. I had the 36 plus 3 that they gave us. And then I did the thing again, and it gave me 7.94 times 10 to the negative.
Okay. We're definitely using yours.
Okay. That's fine. For number 4, I just like wrote out the equation that like frequency observed equals the S VW plus V, or the plus minus the observation over VW plus minus VS. And so I said it's real, and I said because they have the 2 separate frequencies, that there can mathematically be a difference between the 2, so that it's real. I don't know. That's what I said.
I said the Doppler effect is when the observed frequency is different from the actual frequency due to motion. So with the formula you just said, the frequency of the observed can be different than the frequency of the source. Therefore, the Doppler effect is real. So pretty much what you said.
Okay. You just actually explained it better instead of just writing it. Yours makes more sense. All right. Give me 1 second. I gotta go. Somebody's like knocking on my door.
That's fine.
The company, you're saying it's on the company, they should have known about this earlier, but we have seen here though that a higher level of sophistication on the part of Russians than we realize, in trying to divide America by race, by geography, by religion. Russians are fairly sophisticated.
All right, I'm back.
Welcome back.
Thank you. All right, what problem were we on?
5.
Okay. Okay, for 5, I took the same equation I wrote out in number 4, and I arranged it to solve for the VS. So I had VS equals VW, and then the parentheses, observed frequency minus source frequency divided by the whole thing by the observed frequency. And that gave me 3.05 meters per second.
3.0. That's what I got.
Okay, perfect. What did you say for number 6?
So for number 6, so anything higher than the fundamental frequency is an overtone, but the fundamental frequency is not an overtone.
Yeah.
Harmonics are all the resonant frequencies that are integral multiples of the fundamental frequency. So all overtones are harmonics, but all harmonics are not overtones.
Okay, that's like exactly what I wrote. Perfect. All right. How did you do, or I guess I'll tell you how I did it. For number 7, I used the equation that they had in the book that was the frequency equals V over 4L. And so doing that, I multiplied 4 by the 256 hertz they gave us. And then I multiplied by the 0.336 meters. And that gave me 344 meters per second. And then to get T, I divided that by the speed of sound, which was the 334, and I multiplied by 273, and that gave me 8.23 degrees Celsius. And then
What was that?
8.23 degrees Celsius.
So I did mine different.
Okay, how did you do yours?
So after solving for the 344.06 meters per second, I plugged it into the equation V equals 331 times the square root of T over 273.
Okay.
And then I solved for T, and then I converted it back to Celsius after plugging everything in, and I got 5 degrees Celsius with that formula.
Okay, that makes more sense because I'm looking at it now and it looks like I multiplied by 273. I don't think I'm supposed to add 273, so that makes sense. How did you do number B?
So B, so the L prime equals 3L because it's at the second overtone or first overtone but second resonance.
Mm-hmm.
So it's 3L. So you just take the 0.336 times it by 3.
Okay, that's what I did. And you got 1 meter, right?
Yeah.
Okay, so then the only thing I messed up on was the temperature. And I clearly messed up on it. So you can use your number 7.
Okay.
All right. How did you do number 8? Or what did you put for number 8 since it's just like writing it out really?
Yeah. So I went to the book, found the chart.
Yeah. The like first one's for 8, it's like 50, 60, 50, 50, right?
Yeah, 51, 60, 58, 47, all around there. And then the second one was 108, 110, 118, 105.
Okay.
C is -4, 20, 22, 10.
Yeah. Okay. Yeah, that's what I have. All right. Number 9, I started, but then I wasn't sure how to finish it. So like I wrote out the equation. So I took the beta frequency equals the 2 V's added together divided by B multiplied by the frequency of the observed, and then the frequency prime is B divided by V minus V over frequency. I can't tell what that is. It looks like an H or maybe an N or maybe a B. I don't remember.
Okay.
Then I combined both of those, and the final equation I got was F prime equals big V plus little v over big V minus little v plus or multiplied by the FO.
Yes.
That is right.
That sounds right. So I kind of had to rearrange it,
Yeah.
but pretty much so the terms I used was the VB, so the velocity of blood equals the V of water.
Yeah.
Times the frequency observed minus the frequency source over frequency observed plus frequency source.
Yeah. That makes sense.
And so plugging that in, it would be VB equals 1,540 times 2 to 10 to the 6 minus 500 over 2 10 to the 6 plus 500. And I came up with pretty much, that's funny, 1,540 meters per second. So it came back to the velocity of water.
Huh. Okay.
It actually calculated to be 1,539.23,
Okay.
but 3 significant figures. I'm finding he really wants that.
Yeah. 3 significant figures. Yeah. Yeah.
So,
All right. Well, then we can use your second page, and we can use my first page.
okay.
I don't have number 9 written out. All right then. Do you have any questions? I feel good about it. Like this week, I feel like last week was really easy. This week is not as easy, but it's still easier.
It's not
I
bad.
think, than doing. Yeah.
Yeah.
Okay.
I'm happy about it.
I know, me too. I'm like, it's a nice way to end. Although I was a little mad where it's like the last week of school, and I was like, we still have the same amount of work. It's just due in less time.
I know. I still have to go and edit a paper for English.
Oh, man, you have a full schedule for being an online student this semester.
I did 5 classes.
Whoa. Okay, that sounds horrible. I did one, and I like struggled with it. It's hard to like
Yeah,
be motivated when you're not at school.
it's terrible. I can't wait to go back to campus.
I know. I like kind of can't wait, and at the same time, I'm like, it'll be January. Like, I don't know how much.
Yeah. Rexburg, Idaho in January.
Cool.
On a hill.
I know. People are always like, it looks so small. I'm like, it's not a small hill, and there's a lot of wind.
Yeah.
It's